Welcome back to another video. Today we are going to prove that if n is an odd integer, then there exists integer k such that n squared equal 8k plus 1. That means that do we have this kind of integer? So for example, let's start with n equal to 1. So what happened to n squared? N squared is just 1, right? It's 1 in terms of 8k plus 1. So it turns out to be 8 times which one? 0 plus 1. Okay. And when n is 3, what do we have? N squared, which is 9. And what is 9? 8 times 1 plus 1. When n is 5, n squared, it turns out to be 25, which is 8 times 3 plus 1. Okay, and 7. When n is 7, what do we have? N squared, which is 49. And 49 is 8 times which number? It's maybe, I can't figure out right now. Maybe 6, okay? 6 plus 1. So, let's prove it. But n is an odd integer. So I want to start with assume that. I'm going to assume that n is an odd integer. Then I gotta consider integer. Okay, I gotta consider any integer, and well, I gotta use 4. Okay, what am I doing now? So typically, if we know that n is an odd integer, by definition, what do we have? By definition, we know that there exists, let's say, a. Okay? Let's say a, integer a, such that n equal to a plus 1. Now, what is n squared? Which is 2a plus 1 squared. Expand it, it turns out to be 4a squared plus 4a plus 1. So, if you write n equal to a plus 1, I cannot have 8, right? I gotta have just 4a squared plus 4a plus 1. And the first two terms is just going to be a factor of 4. Actually, it's just 4a. Okay? I need to have a factor of 8 from these numbers. So I have to consider number 4. Meaning, I'm going to write n equal 4a plus 1 and n equal to 4a plus 3 in order to have odd number n. Now, I consider any integer and 4. So if you have any integer and 4, I can use division algorithm. Okay? So by the division algorithm, what do we have? So there exists an integer q, okay, such that any integer can be written in the form. So it's going to be this form: 4q plus 1, 4q plus 2, and 4q plus 3. Okay, these are 4 kind of number that we want. We can write if we consider integer and 4. But n is an integer. Since n is an odd integer. So what a partial expression of n. So we are going to have n equal 4q plus 1. Okay, or n equal 4q plus 3. And then what do we have? So there will be two cases, right? So I'm going to expand n square when n equal to 4q plus 1 and n square when n equal to 4q plus 3. So we start from n square equal 4q plus 1 square. Or on the right side, we're going to have n square equal 4q plus 3 square. And it turns out to be 16q square plus 8q plus 1. At the same time, when we expand 4q plus 3 square, we're going to have 16q square plus, okay, what is this number? Is 24q plus 9. Then I can now factorize number 8 from these two terms. So we're going to have 8 times 2q squared plus q plus 1. Or on the right side, number 9, I'm going to partition into two numbers. So number 9 becomes 8 plus 1. So I focus on these three terms. As you can see, these three terms, we can factorize number 8. So we can have 8 times 2q squared plus 3q plus 1 plus 1. Okay, so at the same time, we can factorize number 8 out of the first term, the first two terms or first three terms, so that we have 8 times an integer plus 1. Okay, so now I will split into two cases, right? We have to show that there exists k such that n squared equal 8k plus 1. So we start from the first case. The first case is the case where n equal 2q squared plus 1 and plus q plus 1. Okay, that's the first case. In this case, we can choose k. We can choose k to be 2q squared plus q. Then we gotta have n squared equal 8k plus 1. Okay. Now, what about the case where another case? Another case is the case where n squared equal to 8 times 2q squared plus 3q plus 1 and plus 1. So what do we have here? Okay, what do we have is going to be, we gotta have to let k to be this integer. Okay, so we gotta have k, we have to choose k to be 2q squared plus 3q plus 1. Okay, then we gotta have n squared equal to what? N squared equal to 8 times integer k plus 1. So it turns out to be 8k plus 1. Okay, and this is the form of n squared we want. Therefore, sorry for my handwriting, x squared of an odd integer can be written in the form. This form is 8k plus 1. Okay, where k is an integer. Okay, that's what we have. All right. That's what we have for this video. Okay, so this is how to use the division algorithm. Now, that's it for today, and see you in the next video.